Hi, welcome everyone. Welcome to ST Skills. This is a weekly system design series that we conduct on like Saturdays at 9 a.m. PST. So the format of this is we do a mock interview in 1 week. Another week we do a deep dive on one of the topics. So if you'd like to be part of this mock, or like if you'd like to present a topic in one of the sessions, please sign up in sport.stskills.com, or you can ping me in Discord. And note that this is a volunteer driven. So like all of us come here together to learn. So today we have Abhishek doing a interviewer role and Alex as an interviewee. So, and we are having a mock interview. So over to you, Abhishek.
Hey, hello, Alex. I'm Abhishek. Uh, Today I'm going to be your interviewer.
Okay.
So we are going to discuss a system design problem. And before we jump into the system design problem, I just want to briefly hear about how much work experience do you have, and what part of software engineering stack have you work experience in?
So I have around 3.5 years of experience. I work at Amazon and I work on the tax storage platform. And the tech stacks I have worked with is mainly backend Java related and like
Okay.
AWS technologies.
Awesome. Okay, great. Okay, so Alex, so we wanted to build this airline aggregation service where user can search for the airlines, right? And we will show him the results, and then we will allow him to book those airlines. So something like Expedia or something, right? But just limited to, let's keep it limited to airlines.
Okay.
Yeah, so this is the system we want to build, and I want to know, like, if you would have to build this system, how would you go about building such system?
Okay, so like for the airline system, like a user can see like a list of airlines.
Yeah.
And like it's not just one airline, it's like from different airlines. Is this like app like global, or is it like can we like concentrate on just like one location?
If you think that one location will be easier for you, we can start with that. But eventually, we want to go with building a global system where where we are providing results from multiple airlines. So basically, we are not building airline system for one particular airline. Like, we are not building for, let's say, Singapore airline or something. We are building an aggregation service where we will get the results from multiple airlines. And so in that case, we would want that we have data of all the airlines. Otherwise, we are not a good aggregation service, right?
Okay, got it. So like how do we get the data of the airlines? Is there like an API we talk to, and can I just assume there's like each airline has their own API?
Yeah, exactly. Yeah, very good. Yeah, so that's the thing. Yeah, so we can assume that we have some contract with these airlines that we can use their APIs to get the up-to-date information from them.
Okay, and like what information do we need from the do we get from the airlines? Do we need like to manage like the seats on the plane, or like, and like what about fluctuating price? Do we have to worry about that?
Yeah, let's keep it simple for now. So let's assume that we are just allowing user to book a flight for a particular price, and right now we are not worried about seats and all. So just booking a flight seat if it is available and for that particular price, right?
Okay. So is like the user interface, like signing up for like a user account and like payments, is that also included in this design?
Yeah, great question. So let's say we have some friends, friend teams who have already built a authentication system for us, and we also have uh, already a team for payment, so we can use their APIs
Okay, so
for that.
okay. So like let's like one use case, like the typical use case would be like customer goes on our website and then searches for like a particular location, like or like two locations. Like, do we support round trip as well, or like?
I would let's keep it very simple for now, that there is a source, destination, and this is the date I'm looking for, right?
Okay,
And I want to get the flights. So yeah, I mean round trip and all that could be later extended. I don't think it's very important. So yeah.
okay, so a workflow would be like the customer inputs their source and destination date, and then on the web page, a list of like the airlines with the destinations and dates is available.
Yeah, exactly. Yeah, with the price. Yeah.
Yeah, with the flights. And
With the flights and price, right? Yeah.
yep, flights, inputs, okay, flights and price. And also the seat number. Does that make sense?
Yeah, I would say so I'm saying let's keep it simple. So let's say
Okay,
we will just show that how many seats are available. You can book, but we are not concerned about booking a particular seat or something, right?
got
So
it, got it.
yeah.
So like the customer can like choose like X seats, but then if there's the
Okay,
number of
yeah.
seats is not available, then
Yeah.
we'll return like an error in that
Right,
case.
right. Yeah, number of seats you can specify, yeah.
Okay. So the customer can select like a number of seats. Okay, that makes sense.
Yeah, right.
Okay, I think this makes sense. So how many users are like we expecting for this site?
Yeah, so let's say we have around 10,000 users viewing our site per second.
Okay. And like how often, how many airlines are there? Like how many airlines do we have to fetch information from?
Yeah, how many airlines? So let's say we have around 2,000 airline companies that we talk to.
Okay, 2,000 airline companies. Okay. Okay, this makes sense. Okay. And like how concerned are we like about like how quickly the information is displayed to the user? Like do they expect it in like a couple milliseconds or like?
Yeah, so that's a good question. So we would want that we are providing as much low latency as possible. And now it's up to you to tell me that how much low latency can we actually provide in the system.
Okay.
Right, but as a service, I want it should be low latency so that my customer don't go to some other service which is lower latency than me.
Got it. Okay. I'm gonna start with like a high level design of what I think.
Yeah.
So I'm just gonna have a block here. So we need like a service to interact with like the airline APIs. So airline download service. So basically this service talks to the other APIs, talks to other airlines to get information. And like, I think we need like pretty quick access for like this information, like from the airlines, because like we don't want outdated data for the customer. Like if like the seat number is like has decreased like already when the customer sees the data, then it wouldn't be good user experience. So I think we need like a in-memory cache. Actually a distributed cache, so like Redis or like Memcache. And we also should store the okay, let me think about this. So I think like every time like a user requests, we have to like get the information from the APIs if we want like really low latency. So it makes sense to just store this in like the cache without like storing in any database. So actually, yeah, so writes to a cache. And I'm just gonna draw another service. So this is like so I forgot to ask, like, are we developing like a web app or like, is it like mobile too, or like?
Yeah, let's say for now it's just a web app.
Okay, so it's just like a web. So, okay. Okay, so I'm just gonna separate like the web app and like, okay, have some like API service as well. So the web app would be just like calling the API, or so this is like our API service. So something like, so when a customer interacts with the web app, it will call the API service, and the API service will call the airline download service to get the latest information from the APIs. And let me, okay. So, okay. So I'm like thinking about like how how we can like keep track of the number of seats. So like, let's say like a customer is like booking some seats. Do we like tell the airline service that like we're booking some seats, or do we do it like through their portal?
Sorry, what's your question? Do we?
So like, let's say a customer like wants to book like a seat for like a flight.
Mm-hmm.
Like, how do we notify the airline that like we want to hold those seats?
Okay, so you are talking about the booking piece, right? So
Right, yes.
Let's separate this into two components, right? One component is we want to get the information, what are the seats, right? That read part, we are reading all that information. And another piece is booking, when the user want to actually book the right path, right? So so if you're talking about booking path also, again, we can make an API call to that airline, and then they will let us know whether they can book that seat or not.
Got it. Okay, so it's not just, this would be like a API, airline API service. So and let me just like, so we would have like the aggregation service, which writes to the cache. And then we would have a booking service. Which I will think about later. So, okay. Okay. So like right now I'm thinking like about the flow. So so this aggregation service basically calls the APIs and like, so, and aggregates all the data based on the dates and the source and destination. So gets data from API to and compiles source, destination, airline, date. This booking service also calls the API. So I think there are multiple states for like the booking service. So one of them would be like reserve a seat. So reserve the seats. So is there like a time limit, like a customer can reserve a seat, or do we just like let's say like somehow the airline runs out of seats while the customer is reserving? Is that like is that behavior acceptable? Like, do we just return error?
So can you explain this scenario in more detail?
So let's say like the user clicks on a flight and before the payment goes through, the seats are gone. Like, what do we tell the user? Or do we just like...
We can say, yeah, that, sorry, this flight is no longer available.
Okay, got it. So...
so yeah, I mean, if you're asking that, do we want to hold the seats while the user is viewing and all those things? So yeah, let's not complicate. Let's keep it simple, that if the user is asking to book, then only we try to book it. We are not holding or something.
Okay, so so there is a payment service, and when the booking service, so the booking service, when the customer gets a seat, then a booking service will be called, and the like first booking service checks if so when the payment service goes through, so I'm trying to think like if we need to process like like the payment needs to be processed first before we tell the airline, transfer like the data to the airline that like it's booked, or like after.
Yeah.
So let's say like the customer actually pays, and then the airline, someone else in some other, from some other service, like buys the last seat and actually fails. Do we like refund to the customer in that case?
Yeah, these are very good questions. So basically, we have these two systems, right? Payment system and booking system. These two are different API calls, and we want either both of them should succeed or both of them should fail, right? We want to implement kind of a distributed transaction on these two services, right?
Got it, got it.
Yeah. So now, yeah, we have multiple options, and one of the options which you have mentioned is that we can issue refunds or something like. So yeah, we can discuss about, do you have any other approaches in mind that if the payment was succeeded, but the booking failed, we can refund the money? That's one approach. Is there any other thing we can, other things we can do?
Yeah. So like two-phase commit. So like if the payment, if both, we have to check if both booking service and payment service succeeds. And if both of them succeed, then we tell the customer that it succeeded. But like if one of them failed, then we will return like a failure to the customer. And I assume like the payment service has like some way to hold, like put a hold on like the credit card. So we won't have to actually charge the customer until like the booking service goes through.
Okay. So in two-phase commit, so are you going to, so the point here is, so it's easy to implement these two-phase commits if you have your own system as a whole, but here you are making call to two independent services, right?
Right. So like, wait, so the payment service is not owned by our team, so it's like a third-party service. Is
Yeah,
that what I'm getting? Okay.
yeah,
So
yeah.
like something like,
Because you don't own those credit card companies, right? You have just a contract with them,
got
and
it. So like it's like Stripe or like some third-party
yeah,
API.
yeah.
Okay, so this is actually not owned by us. Okay. Then yeah, I don't think two-phase commits works right here because we actually don't own the service. So I think the best way would be like what I talked previously about, because there's like no guarantees that like both of them can succeed at a time. So in the rare case that the payment fails, so actually let me ask more about the payment service. Is there like any way we can like have a hold on a transaction, like put like a
Yeah.
hold on someone's credit card?
Okay.
Okay.
Yeah. Let's say we can do that. Yeah.
Okay, so then we would try to book the airline. First, we'll put a hold on like, hold on customer credit card. And then we would try to book. So if booking succeeds, we charge customer and return success. Otherwise, we return fail. Fail. Okay.
Okay. Yeah.
So
Okay.
that would be like overall algorithm.
Yeah. Okay. Sure. Yeah. I think we are good here. Let's move on to this aggregation service now.
Okay.
If you don't have, right? Okay. So like, I have few questions here. So one thing is, so when the user is making a request, are you going to call those 2000 airline companies to get those details, or what are you going to do? What's your approach here?
Okay, I see. So let me expand on that. So I assume like not all airlines are like have like destinations to all over the world. So we need some database to cache, like to store like the typical destinations of each airline. So, and like this database doesn't like we just need availability for like this database, like since we're gonna have to call the airline API again anyways. So there, I think like we should have like a background job that like periodically updates this database. So let me move this part up so I have more space. Okay, so like have like a job scheduler to like periodically populate this database. Okay, so this would be like just for like get source destination for airline service. And like I think we can actually cache, I assume like other than the seat information, like most of the airlines actually don't change their flights too often. So I think like as long as we rerun the job like maybe like every hour, we should get like updated information for most of the flight information. So
Good. Okay. Yeah, makes sense. So, yeah, I agree with you. And so, what exactly data are you going to store in this database? Can you elaborate on that?
Oh, yes. So I'm thinking wait, let me draw the text box. Okay, so the airline, the destination, source, and date. So everything except like the number of seats, because I would expect to like change. Okay, I think we can at least have like are there any seats available? Like, okay, I don't think that makes sense actually. Like
Yeah, it's fine.
someone
Yeah,
could like cancel their seat and then like the seat number doesn't make sense here. So
yeah.
just airline destination source and date.
Okay, okay. So this is the information, and uh, so this information you're going to store in DB. So, like, can we estimate how big this information could be? Like, would you be so are you going to store this information in one database, or like how are you going to store it?
Okay, so let's say airline name is like maybe like 100 kilobytes, and the destination would be like airport code. So I think it's just 3 characters. So like maybe like let's just like give like a bit more. So like 50 bytes. And the source would also be like 50 bytes. Oh, okay. I don't think the airline would be like that. Okay, I'll just give and the date would be like a timestamp. So I think it's like 8 bytes.
Okay.
So everything like let's just like leave some space for like optional metadata. Maybe we need like so I think maybe like 100 kilobytes. So I don't think like the total would be more than like 250 kilobytes. So let me put 250 kilobytes, and then we have 2000, and we aggregate like every hour. So there's like 24 hours in a day. 365. Okay, I don't have a calculator right now. Okay, let
No,
me.
yeah, no, yeah, it's fine. We don't need to do exact calculation, but uh,
Uh,
and how about like so? Is there anything else missing here? Like, are all these things we need here to calculate the data size, or is there anything missing?
let me think. Oh, okay. 20. Mm, 23, yeah, I can't really think of anything missing.
Okay, probably, yeah, no, that's fine. I was just thinking that you also need to store the combinations for source and destination, right? And you
Oh,
also need
okay,
to
right,
calculate how many
right.
combinations of those you can have, right?
Yeah, I totally missed that
Yeah, no
point.
problem. Yeah, yeah.
So can I assume that there's like I think 200 destinations and like 200 combinations of destinations and like 200 combinations of sources.
Mhm.
Can I just like assume like 200
So
sources,
it's cities,
200,
right? So your
right.
source and destinations are
Okay,
cities,
okay,
right?
okay. There should be
And
much. Yeah. I
and
was
so
like,
it could be like, let's say,
would be
like
like,
you have.
yeah, it'll be
I know I would
much
say
more than,
that there are much more cities. Yeah,
there would be like
like
20,000 cities.
20,000 cities, right? Yeah.
And
Okay.
like, yeah, 20,000. So, okay, I see. So the data would actually be like huge.
So
So we would have to like overwrite the data or like purge data periodically to like clean up space.
okay. Mhm.
Because like it doesn't like we don't need the data forever. We can just like have like the data expire. So like a background job just to delete like the ones that we don't need. So like all the expired flights. But even then, like there's actually like how many flights are like in like how far in advance do like customers usually get flights? I would like assume maybe like 1 year,
Yeah,
maybe
yeah,
1.1 year on
yeah.
average. So 1 year on average. So we still need to store like yeah, this would still be pretty huge even if we purge it because we still need like yeah, we still need 365 days and 24 hours of data pretty much.
Okay.
Pretty much I
Yeah.
think this still stands. So this database, so I think like we should like regionalize the database
Okay. Okay.
at least because like at least like closer to like where the destination address is because I assume like most people would book flights from the destination they're already in
Hmm.
and then so maybe like use like 4 regions maybe so divide the database into like four like like North America, Europe, uh, Europe, and like maybe like I guess like China has their own laws maybe, so I'm guessing like China and like everywhere else, something everywhere else.
Okay.
And this is like a NoSQL database, so most NoSQL databases like scale automatic have like auto scaling features.
So you have chosen NoSQL database here,
Yes.
and why is that?
So I don't think like so this information doesn't need to be updated very frequently, and we don't really need like relational information like for like SQL databases. Like we're just looking for like availability and not consistency.
Mhm.
So we're looking for a consistency, like availability, not consistency. Like even if like the information's like a bit outdated, we still have to call the APIs to get the number of seats.
Yeah.
So if there's like even like a couple of minutes delay, I think it's okay, even if like the information is a bit stale.
But stale in the sense that
Oh,
if you have extra airlines, but if you don't have the airline and which is now serving the data,
I
in
see, I
that
see,
case, that stale information is not good for you.
I
But
see, I see.
probably okay, we can go over there later. So I want to understand here. So you are saying this much data. First, can you fit this data in one database machine, one machine, or are you
It
saying
would
that
be
you're
like
going to divide it into these four?
definitely like distributed.
So,
So
mhm.
depending
so yeah.
depending on like how much traffic we have. Like so we have to make about like 2,000 calls. Actually like 2,000 times 20,000 times 20,000 calls, I assume.
Mhm.
So we definitely have to scale this, and the key, I think the primary key would be like the airline would be like, I think like a hash of the airline. And okay, let me think. So it'll be like airline, like combined hash of like airline destination source would be like the key. Because like I think like every entity that we store in our database would be like a mixture, would have like unique values for and dates. So the whole thing would actually be a key, if that makes sense.
Okay. Yeah, it makes sense.
So every entry would have like, I'll use that as like the key. So we can like shard the database like using consistent hashing, which most NoSQL databases I know of already have that built in.
Okay, so now you are saying we're not sharding the data on the basis of region. We are sharding the data based on these hashes. Is that what you're saying?
Right, yes. But the databases should also be regionalized just so then the latency can be reduced.
Okay, yeah. Mm-hmm.
So the databases will be regionalized, but then we will shard based on the 4 fields.
Okay.
That,
Right, okay.
and the airline would still have to call the services for the seat number. So let me draw this. So the aggregation service. So there would be like a second call. And this one, I think like we need the data back like right away. So this would be like get seats. And this would happen like every time a customer calls like the web app to like request, like every search pretty much would have to fetch the seats again from the airline's API service.
Right. So I think, yeah, so to summarize, I think we have built this system where first, if someone is looking for some airlines, first we will go to this database, right, to find out what APIs we actually need to call, because we don't want to call these 2000 airline companies, right?
Right, yes.
And from that, we will get the list of airlines that are serving for that source and destination, right, on that date, right?
Right,
Looking at
yes.
this database.
Yeah.
And then once you have those airlines, then you are going to make a call to those airlines to now get those seats. Is that
Right.
correct?
Yes, that's correct.
Okay. So, okay, now I want to dig deeper into this caching thing which you have discussed. So now in this overall system, what parts do you think could be cached and how are you going to cache those components?
So definitely the seats need to be cached. Oh, okay, let me think more actually.
Yeah, no problem.
So I think there are actually probably some destinations that are like more hot, like people, I assume like customers will actually view particular locations more often than others. So I think it makes sense to cache maybe like 20% of like the hot destinations, source and destinations. So we don't have to look it up in the database that often. Like it would save some time. And like the seats of those would be like cached as well, just to save.
So are you talking about caching the airlines that we want to
Right,
call? So
yes.
those, okay,
So
okay.
I think like some airlines should be cached just to, so like the, like, let me draw a text box here, okay. So the top 20% of airline, of destination, airline, destination, maybe just like the destination source based on the top destination, 20% destination source combination, like the information from this airline destination source state database should be like put in like a cache
Okay,
just for
okay,
quicker access. Because I
right.
assume like most users would search those locations.
Okay, got it. So this is the cache we have built over here. Okay,
Right.
and so this is the first part, right? Where we get the airlines that are going to serve. Now the
Yes.
second part was now
Uh,
making a call to airlines, right? And
right.
so what are we doing over here?
So for the seats, we also should put it in the cache because like we don't, there's no point in storing this data, and we need because like it'll just change very frequently and we need quick access to them.
Mhm.
So the seats would also be cached.
And how are you going to make sure that the cache information is not stale?
So like I think like have like a time to live on
Mhm.
the cache. So I think like has to be like pretty short duration. Like
Okay.
I assume like airlines have like some SLA
Mhm.
for like how often they refresh their information. So the time to live should be like based on their SLA, like the
Mhm.
lowest SLA, I would say.
Mhm.
So would equal lowest SLA of airlines, something like that.
Okay.
And yeah, that's what, yeah, I think that makes sense. Does that make sense to you?
Yeah, yeah, that makes sense to me. So you are saying that you are going to uh, build this cache. So probably you are first going to look in the cache, right? And this
Right.
cache will be invalidated by the time to live. So
Yes.
if you can get the seeds information from the cache, you will get it from there.
Right. Yes.
Otherwise,
Otherwise,
uh,
have to like do API call again. Yes.
So, okay.
And I think like before booking, we should check again. Like right before the bookings, like on the booking, like when the customer, let's say, goes on the booking page, we should do another call
Mhm.
just in case.
Yeah, yeah, right. Makes sense. Yeah,
So
I mean, I think while booking, we will anyways make that final call, and it will be up to the airline company to accept that booking or not, right?
Right, yes.
Yeah. So, okay. So, right. So, okay. So, that's good. I think we have covered most of those important blocks. So now let's consider the scenario of failures. Like, what components do you think can fail here, and how can we make our system more resilient to those failures?
Okay. So, like for the web app, it has to be, we need definitely like a load balancer.
Mm-hmm.
Okay, let me move this down a bit. Because like we don't want like just one server wouldn't make any sense because we have like 10,000 users per second. Like the web app would definitely go down. So we would have a load balancer balance the users. So
Okay, let's say we have a load balancer that balances. Okay, what next? What other things do we need?
multiple app servers.
Yeah, okay, multiple app servers.
And the API service would also need another load balancer and another stack, because like when like let's say like a customer just keeps searching, or like even if like the like just like a traffic amount is like huge.
Mm-hmm.
And then for our aggregation service, like just to meet like the like have like the information like stored in timely manner, there are too many like API calls that we have to call, so we also need like this also needs to be like distributed.
Mm-hmm.
And like yeah, like and also like the seats service would need to, because there'll be lots of calls, so that basic. And the booking service, I think the booking service like does not need to be scaled up as much as the other services, because
Mm-hmm.
I think like a portion of the customers would just book service, most of them would just search, I would assume.
Yeah,
So this
definitely.
one would
Yeah,
be like just it'll need to scale up as well, but like not as much as the other ones.
yeah, okay, yeah, I agree. Uh, so one scenario I was thinking of was that, so when you found out that for this source and destination, let's say you call to these 50 airline companies to get the information, right?
Right.
And so you are making those 50 APIs call.
I see.
So like, so what are those latencies over there? How can we optimize the system? You remember we talked about that we want to keep the latencies as low as possible. So what are the things we're going, and probably some of the calls might fail from some airlines, right? So all those things.
Right. So there's like two parts to this. I guess like the first one would be like this the get source destination for airline service. So I assume like there would be a lot of failures, so we need like a retry mechanism to like put the failed calls back in like the scheduler.
Mm-hmm.
So we can retry like after like some time, maybe like an exponential back off.
Mm-hmm.
So, and in the meantime, we would just keep the stale data. Like, I don't think it makes sense to delete the data, because like maybe like when the customer requests for seats, then it would still like we would still be able to get data from those seats. So, and
Okay.
it doesn't really like in most cases, I don't think it changes too much.
Mm-hmm.
And
Okay.
for the APIs, like when for getting the seats, I think like maybe like it doesn't make, let's say like a customer searches for like thousands of seats, like matches like thousands of airlines. It doesn't make sense like to match all 1,000, load the seats of all 1,000 airlines. We can just like, it wouldn't even display all on like, I think like it would be really bad at user experience if we show all the airlines. So maybe like have like a ranking system of like which airlines are preferred. And I assume like maybe like we have like some sponsors, so we should probably show those results first as well. So like some sort of ranking system so we can cut down on like the API calls. So maybe like the top like 20 airlines by some ranking service. So some like
Okay, yeah, makes sense.
ranking service.
So my question here was about this one issue that, so we know that we have to call 50 airline companies now. So we'll make those 50 API calls, right?
Right.
And so now let's say if one of the airlines API is taking too long to respond, or let's say 5 of those are taking too long to respond. So how will we handle that situation?
So I guess one way would be just not show it to the customer at all. So if there is at least like a couple results, then it makes sense. Like the customer can still see the airlines. Another way would be like have like not tell them the seats and just say like seats left would be like unknown. Or like there could also be like another case where we just tell the user to please try again later. And another possible way is just like have like a retry mechanism, like maybe on the client side. So then they can continuously like pull for like seats, pull like ping our server like for seats, like to update, like so it could update in like close to real time, like maybe like every minute or so, like check the server again.
Okay. 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 Yeah, makes sense. So one last piece I want to ask, and then we can close the discussion is, so in this overall system, like, what do you think that how much stale information can we have? How much stale data? And if we want to measure, let's say if we want to measure that this is our freshness level of data, and how will you measure that?
Okay. Like, wait, by stale data, do you mean like the data that like is not like fails to update every time we call the API, or like the data that just never updates? Like after API call, we get the same information.
So my question is, so let's say everything passed, nothing fails.
Okay.
Can we still show stale data, or can we not show stale data then?
Okay, I see. So I think we can like just remove the stale data. Like if the date is like passed, then definitely we can remove that data. And like for all the destinations, we search it again, so it won't be stale anymore. Okay, I see what you mean. Like we don't actually have to keep we don't have to keep updating the information like.
So see, my question here is just to explain. So you said that this table where you get list of airlines, you refresh it every 1 hour, right?
Yes.
So now think of this scenario that you have just refreshed your data, right?
Yes.
And now just after the refresh, another airline comes and say that now I'm also serving this source and destination. So, but for 1 hour, you will not update your data, right? And you will be, because your job will run after 1 hour. So for that 1 hour, you have the stale information. You are not showing that new airline, right?
Okay.
So
I see.
yeah.
So your question is like, what's like acceptable time for like stale data? Or
yeah, I just want to ask you that, so this is one scenario. Are there other scenarios where we could show stale information? Like, do you see other components of the system where we can see the stale information in some way?
Like all other places where we can show stale information.
Yeah, which is not up to date. And like, so.
I guess like the seats we can show stale information as well, but
Mhm.
like up to like if there's like a very low number of seats, let's say like 10 seats, then we should not show that because there's a high probability it might, like if it's like a hot flight and there's low number of seats, we can like it can be like gone like before, like, and it'll be bad customer experience. But like if there are like a medium to like high amount of seats left, we can show that to the customer, and most likely they will still be able to book those seats even though the
Okay.
information is stale.
Okay. Yeah, makes sense. Okay, great. I think, yeah, these were the questions I had. I think we built up a quite good system. Do you want to add anything else?
I think I'm good like on the components we talked about. Like there could be like more discussions on like how the web app would work, like how we could like cache, like have like all the text, HTML and like stuff in like CDN, and
Mhm.
but like I don't think like that's the main focus of this interview, so that's okay.
Okay, great. Okay, thank you so much, Alex. It was great. We had this conversation.
Yep.
So, hey Naga, I
Okay.
think we are done.
Yeah.
Yeah.
Yeah. Thank you, Abhishek, and thank you, Alex. It was a good mock interview. So there was a lot of good things discussed. Now, like we will discuss the feedback from like the audience, like who are watching, and I can also share my feedback. Some of my quick feedback is, like, I think you did talk about like a lot of good stuff, Alex, like from the interview feedback. So what I felt is like there is no clear differentiating between like read and write parts, like on the flow wise. So I think the components are like mostly mixed up. So I think it's when you draw components, I think you might need to leave space for read part separately and write part so that like it clearly abstracts the, I mean, like it clearly shows to the interviewer.
Got it.
And one thing on the aggregation service, I don't know, like maybe if I didn't catch that, is like I didn't know if it was real time or like an offline, which fetches like periodically.
Okay.
So
Yeah, I think I didn't explain that clearly. Yeah, it is like offline.
okay, so and you rely on like your API service will rely on a database or a cache to get
Yeah.
that data. Okay.
So it would be like a job
Mm.
scheduler.
Okay, yeah, that wasn't like very clear to me. And
Got it.
yeah, and like there is, you also assume like one abstraction called like airline API service, but like in reality, you have like there are so many airlines, right? Like you just probably can say that that component will take care of like identifying the right airline and calling the right airline API. So I think you made that assumption, and like I think that is a good, but like just to you could convey the same.
Got it.
And there could be multiple APIs, right? Like I think in the when you are explaining the aggregation service, you did talk about like again airline API service, but like there could be multiple services. So maybe one for getting all this metadata. Like maybe you can just say one get metadata service, which probably gives like their availability of different flights on several dates, and another one just to get seats availability, just like two logical APIs on airline spread, just to differentiate the flow.
Yeah, that makes sense. Yeah, I totally missed that part. Definitely.
Yeah, and that's okay. I mean, like there is a lot to discuss, like, but um, and I think on the booking service, you like make like how the transaction booking transaction works, and using the distributed transaction concept, that was fine. And one thing on the seats availability, again, like you, you didn't talk about any overbooking or like are you maintaining up-to-date seats availability? So that was one thing that could have helped. I think that's my high-level feedback, and I'll probably come back with any others. And I think one of the audience I'll let probably Rahul share. So he brought up about Rahul brought up about the concept of transit flights. So I think which you can make assumptions whether you are supporting or not in this requirements.
Yeah, makes sense.
Yeah,
Hey,
that's it.
one thing I want to mention is, so this was my first experience as system design interviewer as well. So
Yeah, I
from the
think
audience, I would really want to hear the interviewer feedback as well and things that I could improve on.
Okay, yeah. So Abhishek, I think you did like overall good job, but yeah, one thing I felt is like maybe you aren't probably you are trying to ask the questions to challenge Alex, but like I didn't feel like he went out of comfort zone anywhere. I mean, like some interviewers tend to do that, but I don't know if it's always needed. But like Alex was mostly answering most of your questions. I don't know. Maybe I think you need to provide your feedback as well on that. But overall, I think you did good job. I think Vivek is also there. Maybe he can provide some more feedback on that.
Okay, yeah, thank you.
Anyone else wants to provide any feedback?
I can
I mean,
provide.
yeah, go ahead, Asim.
So overall, I felt a really good experience for me to watch both Abhishek and Alex talking, and I like the topic as well, this airline booking system, because there are a lot of components in that, and there are a lot of discussions could happen. So I felt like a good topic. Looks easy, but it's pretty tricky and complicate how we drill down. So I like the topic, and overall, I liked how Abhishek was steering. I always felt like a conversation is happening, and two engineers are talking and discussing that, hey, how to proceed further, okay, what you'll do here and what you'll do, and back and forth they also clarified, okay, and have an agreement that how to proceed further. So I like that, and so to come to particular in Alex for now, I felt like Alex has this format. He went through his functional requirements and went non-functional requirements, come up with a design, and he able to split into multiple components, which is good. Like I felt it is almost like distributed system and microservices architecture. So every component was different. And overall, Abhishek and Alex able to drill down a lot of components, able to even reach at the end with the conclusion, like, okay, this is the system look like. So that is actually a good sign to end with. But if I have to tell how things could be done different, if I have to do it, and it could be my personal thing. So I felt there could be not multiple, couple of places where we could have avoided going too much into components or drill down into components. For example, this booking part. If I would be there, first thing I would have asked interviewer, or I could have proposed, okay, the booking part itself I'll give to the airline. Can I just redirect to the airline and they do? And there are examples like Google. If you go to Google Flights, they actually redirect to you to their website. And other thing is, or if the interviewer say no, I don't want to redirect, then I'll say okay. The second thing, okay, I'll just call their API, payment, everything they will take care, and they will tell me if the flight is booked or not. I won't go into that cycles, like how the transaction or payment will look. And I think this is how actually it also works. If you see at your credit card, there is never like Expedia.com. It was always like Cathay Pacific or something, because the end airline make a transaction. That's what I feel. So I will try to give that responsibility as much to the airline API, and and I'll take most of the responsibility of showing, displaying things, and and wherever I could redirect, I would redirect them. And other thing I felt like the high level diagram could have been come really quick. Like if I have to add something here, so I'm just annotating something, but this is again my opinion. Like high level diagram could become really quick. Sorry, I'm just drawing. Like this is my website. This is my client. This is my aggregation system, which would call different airlines. And then there is another component which is doing my booking system. And then I could come back later, or like I'm redirecting to the airline or whatever. And then after defining all these components, then keep on drilling down. Oh, how my aggregation system will look like. What would the issues there, and other things. So I would, if I would be there, like I would really able to come quickly on the high level and then keep on drilling down into certain things. Other thing, what I felt, and correct me if I missed something, I felt there could be another critical thing is a price thing, which I would like to see. I would not be so bothered about the seats if I am a customer. I would be bothered about the price, like what is the price the airline is offering me, and if there is a dip in the price or a hike in the price, it should give me some kind of a real-time thing. Seats is okay. Seat is always, if you see a airline, they always overbook, and if they are almost overbooked, they remove it from their charter, and that aggregation component can take care. Like if now airline this flight itself is not available, then don't even display. That's what my understanding. Like when I book flights, I generally book a lot of flights, so they actually remove it if they see like it's overbooked. So this was like over, and yeah, and on the cache thing, I think the cache was an destination source, but I thought. Can you explain like actually I got lost. Like what was the destination source combination of cache?
So like I was thinking like like most users would like search like a destination source, like and like the hottest destinations and source should be like combination. So like airline destination source and date should be cached of the top 20 destination source pairs.
Okay, so so caching would be on the destination source, airline, and the date time, right?
Right, yes.
Okay. That makes sense now. I thought it was just a destination source. So yeah, so that makes sense if you are caching on that. But again, I would like to see if you are also caching on something like a price also. That could, I feel like, could be another critical piece which I would like to see. So overall, I felt like you covered a lot of things. You have a good hold on uh, databases. You're able to define, okay, how my database should look like, and how you will scale it when you have a lot of records, and how your components will talk to each other. So overall, I felt it was a good discussion and design.
Thank you, Asim. It was good feedback. And others, like anyone else, like Praveen, Uday, or
Hey, Alex. Alex here too. I would like to mention a few points that I noticed during your approach in attempting to solve it. I think you did great. You probably would be a hiring, depending on the level. But I noticed that you took a few, I would say, risk decisions too early. One of the first decisions was to add a cache to the systems right at the beginning. And why I'm saying it's a risk movement is it was not quite clear what problem you were attempting to solve with that cache. And which showed to be the case later when the interviewer starts asking you about the data you need to handle or how you need to solve the problem of latency or stale data. Because if you think about the main problem here is delivering data that's not stale and in a minimum amount of time or minimum latency. So I think you should have spent a little bit more time exploring the problem before start drawing a high-level solution. And then maybe you could notice, or you would be able to notice that a cache, even though it might make sense, it's a very complicated thing. Can you understand what I'm saying?
Yeah. Like, I think I jumped on the question too early, and I just like was blindsided by like the low latency, which is why I chose the cache. But it makes sense. Like I think like the cache actually, like in hindsight, the cache isn't like an important part of the aggregation service. It's actually not, and it's pretty complicated. So
yeah, it can be tricky to determine how this cache is really going to work when you have this requirement of not giving stale data. If you think about number of seats change quite quickly, and also flights can be canceled because something bad is happening and your system is not aware of that. So if I were you, I would be wasting a little bit more time trying to understand, okay, let me draw here what a user is really going to do. So he types a query, I get this and this piece of data. I need to send that data to the flight, to the airline. Okay, what airline is going to answer me? So quite of defining a little bit more what are the messages that are exchanged between the multiple components or services that you have. But I think you did great. You were able to come up with some quick solutions for some of the tough questions asked by the interviewer. And that was interesting to see. Some guys out there get stuck, they don't move ahead. And you were able to kind of keep the flow of the interview. Was really interesting to see that. So yeah, congratulations, you are hired.
thanks.
Yeah, I agree.
Thanks, Alex, for providing the feedback.
Yep, thanks.
Anyone else?
Like, I want to talk about like my interview experience. I think it was very
Sure.
good. Like,
Mhm.
like I had like a few other ones, and like there just isn't much interaction from the interviewer, and I think like it just really helped like the flow of the whole interview.
Okay.
Like I
nice
wouldn't
to
have
see.
to like just pick
Mhm.
something like I'm interested in talk about. Like there was actually a good discussion, and it was like really fun.
Yeah, I mean, to add to it, so like actually I have also experienced this myself. So the problem which happens is like in a system design interview, there are so many things you want to talk about, and so you have to show your knowledge also, plus you also struggle with organizing your knowledge, like in what organization you have to show your knowledge. So that's why I wanted to help Alex in some organization piece, because sometimes the candidate might have some knowledge, but he's not sure that what to talk about and how to organize his information. So if an interviewer can help him a little bit in organization, then we can make a good productive use of time of those 50-55 minutes. So, yeah.
Okay.
But yeah, I mean, I'm going to provide my overall feedback in the end once everyone has provided the feedback. So,
Okay. So, anyone else willing to share their feedback? Vivek, please go ahead. I think.
I can go ahead as well. Thanks, Naga. I think first of all, it was like a terrific performance by Alex. I mean, you felt super comfortable with the design, with the conversation. I think Asim mentioned as well, said that this looked more like a conversation between two engineers and didn't look like an interview. That is perfect. Did not need a whole lot of like redirection or channeling from the interviewer. So essentially, you were going in the right flow. And I think, as you said, Abhishek helped you along the right way, but it didn't sound as if you were going in the wrong path and Abhishek had to guide you in the right path, right? So a typical interview has a lot of those scenarios, and that didn't happen here. So a couple of specifics I wanted to cover, which were not covered thus far. Like one is essentially there is like a good design hygiene. Like in general, you have broken things down into specific components. There were separate parts. Functionality was encapsulated in the right places. It didn't look like the wrong component was trying to do the wrong thing at all. So a good degree of abstraction. I think if you look at all the encapsulation, abstraction, you have a separation of concerns. I think you've handled all of those reasonably well. And these things are hard because usually it's very easy to go and stick a functionality into something else where it doesn't belong. Especially as the design and the requirements are evolving, it's very hard to keep that purity of design. But you've done a very good job there. So that part I think was definitely exceptional. In terms of some quick nits as such is one, I think Naga, Asim, and the other Alex covered some specifics, but a few more things were you did use a few rules of thumb, like 20% of this thing would be cached and whatnot. It just wasn't clear as to why you picked that. I mean, in the sense that, yeah, it's obvious and logical, but I think it's just that I would say that, you know what, you just say cached and you'd leave it at that. And then if there is a further probe, then you can say that it depends on various factors. Like, why is it only 20%? Why not 5% and why not 50%? I mean, depending on how much cache you have available, depending on the size of the payload, depending on the kind of usage pattern, you may have to tweak the cache. So the 20% is a rule of thumb, but it just, I mean, it's on point. So I don't think there is anything to worry. But it will help if you either explain the rule of thumb or probably kind of stay away from it if required. Another one, I think the other Alex also pointed out around problem exploration and jumping into specifics of like why did you add a cache upfront and whatnot. I felt the same way about regionalization as well. Like you did have databases in like you have 3 regions: North America, EU, and China and whatnot. It just seemed a little off from the rest of the conversation. It just seemed a little bizarre. But again, I might have missed, maybe there was a lead into that from Abhishek that got you there, but I don't know. So I had 2 other things generic things I wanted to talk about on interviews in general, system design interviews in general. Is I've repeated this a few times, but I think it's worth driving that point home. Is I almost always see these design interviews in 4 distinct phases. And the first phase is essentially requirements clarification and problem exploration. And at this point of time, you would gather the functional requirements, non-functional requirements. You would explore the problem a little, like you will understand some parts of some amount of scale, what kind of thing. You get a feel of the scale. You don't have to design for it yet. What is important, what are the hot button items and things like that. And that's the problem exploration part of it, which I think the other Alex mentioned that you could have spent a little bit more time on some of those things. Like I think Naga mentioned that I think he caught the one around the seat reservation piece being missed and whatnot, right? So spending a good amount of time on the problem exploration, I think in a 30-40 minute interview, which is what typically a system design interview would be once you cut off the introductions and whatnot, I would spend at least like between 5 to 7 minutes on problem exploration. Spend that time because that's going to pay you rich dividends later. The second part of it is the high level design, which would be identifying the big actors, the big blocks of components that you need to build and whatnot. And this would be another like 5 to 7 minutes in total. The advantage of this particular component or this particular breakdown is that at this point of time, once you're done with this, the problem is essentially solved at a high level. And there is no need for like, if the interviewer wants, they can dig into specific angle of that thing. You could take one of those boxes that you've drawn and then you could just go explore that and go into further detail. Like for example, the stuff that you drew on the top around the web app, booking service, payment party, API, and whatnot, aggregation service, then you could just take that aggregation service and blow up. So I think that's exactly pretty much what happened in this interview. So focus on the high level design, the block diagram first. That is absolutely important. And I think Asim mentioned how he could have made it even more simpler. The simpler the better, because you only have 5 minutes, right, at that particular point of time. I think we took a little longer for your high level. Your high level was not high enough in the level. I mean, it was probably somewhere a little lower, which is fine, but pretty good job there. The third thing is the low level design of a specific component where you would explode and then talk about different pieces. The last piece is actually system verification, where you have to go back to the requirements and make sure that the requirements were handled. You did that as you went, but I don't think we just had like a quick check. I think we were over a little, and I think Abhishek asked saying, is there anything else you want to talk about it or whatnot? I didn't see you jump into the verification part of it. In this case, I don't think it would have made a difference, but in some interviews, if you miss like a specific condition, a common example was like, if you had to handle things like ticket not available or seats unavailable or something, and the interviewer had just mentioned that as a specific requirement up front, and then there were like gazillion other requirements, so you missed one of these requirements. So you just didn't mention it, you didn't handle it. It's very trivial, but you just didn't, and those things will work negatively in the interview process. So the verification is important. I would generally spend about 5 minutes, maybe 3-4 minutes just doing that. You have the list of all the requirements up front, so you just go through those and say, yeah, this makes sense, this makes sense, this makes sense. Yep, I've handled all of those. I'm happy with my design, right? So that part of it would be the 4 phases. So that's one thing I keep repeating, but I think it's worth mentioning again. The last point on my point for you and for the candidate in general is just get more friendly and familiar with estimation and back of the envelope calculations. A couple of things you have to be you can do easily is that doing this 24 times 365 times whatever may or may not be as efficient or relevant. I mean, it's like that there are 86,400 seconds in a day, but you don't need to do that. You can approximate it to 50,000 seconds in a day, or like 25,000 seconds in a day, and then do a division based on that. If you're multiplying, you would multiply it with 100,000, because you want to be always on the other side. And we do this all the time, right? When you're like your transactions per second that was given, I think 10,000 per second or something like that. That is an approximation already. So if you want to convert the 10,000 transactions per second to a daily number, then just multiplying it with 100,000 is more than adequate. Like you don't have to multiply by 3,600, multiplied by 24, multiplied by 365, and whatever, right? For the year number, those things may not make sense. Like for the year, I would just multiply it with 400 and call it that. It just makes it easier. So that is like definitely one thing you can do. And the second thing I would strongly encourage is actually switch to scientific notation. Instead of saying 2,000 and 20,000, I would just simply say 2 times 10 power 3, and then 2 times 10 power 4 or something like that. Or you could just write it as 2e3, 2e4. Super easy, super simple, and then you would not be off. You would not make any of those off by 1 errors and whatnot. So that was my feedback for Alex. Any clarifications or any questions, Alex, from your side?
Oh, makes sense to me. Like, yeah, that's a lot of good points.
Awesome. Just switching to feedback for Abhishek. Very surprising that this was your first design interview, because you seem super comfortable at it. You did a very good job with the interview, in control almost all the time. I think Alex was he was a terrific candidate, so a lot easier as well. You didn't have to interject at all, and you didn't have to reposition him a whole lot. The one part I really loved was you helped move the ball along significantly, like on insignificant items, like where that's not important, that's not relevant. Like I think the estimation part is where you said, yeah, that's okay, we can move on, and then you did you moved it faster. So that essentially what it does is that it greatly improves the quality of the interview, and it improves the data that you gather, because you're not wasting time on these insignificant things. So having your your thought process on what is important, what are you trying to get out of this, and what not is important. I mean, at the end of the day, it is not, the goal is not to try to see where all the candidate is struggling. I mean, it's actually, I need to get data about their ability to do this, this, and this, and are they struggling in these things is what you're trying to figure out. So I think you did a very good job there of moving the ball along where it is, where it was insignificant. And I think you did a pretty good job of keeping the entire conversation as a discussion as well. Like as an interviewer, you sometimes, if a candidate is very good, you just shut up and do nothing. And then the candidate just talks and talks and talks, and that might be okay, but it doesn't feel like a conversation. It just feels like you are just there taking notes and observing, right? And that's not a good thing. So, but in this case, that didn't happen at all. So I'm like super, super happy that I was able to watch this interview. So thank you, Abhishek and Alex. That's all.
Yeah, thank you, Vivek. Yeah, I think I applied all the things that you have taught us, and you have done those presentations for us. So yeah, I just applied those things. So thank you so much for your guidance over here.
Awesome.
Thank you, Vivek. And Abhishek, I think it was, I don't know if no one else is giving feedback. I think it's your turn.
Yeah, before Abhishek talks, I think Nishank just put something on chat. I just wanted to speak it out because chat doesn't get recorded on the video. So for capacity estimations, you could actually use some random numbers, like the well-known numbers. So there is a read QPS is RPS, write QPS is essentially QPS. Read to write ratio will help you determine if it's a read heavy or a write heavy system. The network throughput, a typical network thing you'll have is like 10 gigabit per port, and you may have like 4 ports per server. So you could technically have like 40 gigabits of throughput as an estimation. The number of servers required can be just based on division, a simple one. In-memory throughput is typically around 4 gigabits per second, and disk throughput is typically 1 gigabit per second for SSDs, and about, it says 30 MB, but I think it's more like 300 MB per second for hard disk, if I remember correctly. But these are all like, back of the envelope, like numbers that you can use when you're trying to approximate and estimate. So thank you, Nishank, for that. On to you, Abhishek.
Yeah, so yeah, I think most of the things have been already covered in the feedback. There are very less things, and probably I will be repeating myself. So overall, the good things, I felt that the interview went really well. I think Alex did really, really great. He was able to answer most of my questions. I liked the high-level overview of the system, and so I really liked some of the things which Alex has mentioned about. So one thing is like this booking service, it has to make 2 calls to this payment service and airline service, and one of them could fail. So he was proactive about that. And then, so another interesting thing when I asked him question is that there are 2,000 airline companies, and are you going to make a call to them? So he was quickly able to figure out that we could optimize it by keeping a database of what airline serves what destinations. So all these, and I think like whatever question I had, Alex had an answer for it, which was good. So so I didn't see any issues. And the way Alex has organized overall interview, I did not feel that we did not have enough time to talk about things. We were almost able to cover most of the components. So yeah, so that's why I felt like the interview was really, really good. So some of the things that I will be talking about, which he could improve, and I think because he already did good, some of the things would be nitpicking, but I just want to mention that. So one thing, one point I really agree about is this mentioning this cache upfront. So cache could also create some problems in this kind of system with the stale information, and also so probably I really agree that we should have moved that to the later part, because even with that there were a lot of questions that came to my mind, but I just hold on to that questions so that we don't waste time over there. So now looking at the requirement piece, right? So I think one of the requirements that could have been clarified is like availability and like how much stale information are we okay with, because, and in the later part also I discussed this, that so this system, like we have two choices, right? Either we are always making those fresh calls to the airlines and getting most up-to-date information, or we are doing some optimizations, but probably we could have some stale information. So that could be a question to ask, that how much staleness is okay for this system, how much stalement, and I think that could be a piece that could fit in the requirement. uh, then so then when you were talking about this booking service, it's good that you talked about two-phase commit, but I think two-phase commit will not apply here, because although you said that payment service is third party and so I cannot apply two-phase commit, but even if payment service was our own, the airline booking service is also third party, right? So so that's why still you cannot apply two-phase commit over there. um, the other thing wanted to understand more. So that, and I see a lot of people saying this, that if we want to distribute the data, we will use NoSQL, and I don't know what is the strong opinion about this. Like if I would be in your case, I would use a SQL data in this case, because the data is very organized, right? You have this, you can easily represent this data in table format, it's not changing, and you can shard and replicate your data, you have those fixed shards. So I think this data could have been easily put in a SQL database. So that was one piece over there. Yeah, so, and I felt that at some places I had to help you organize, and basically, yeah, I mean, I see it's hard to do, but like, so initially you were mixing this booking service and aggregation service in some places. So I had to guide you there, that hey, let's separate this read part and write part differently so that we can focus on one system at one time. uh, then in the end, I was really focusing on this part, that so you are making a call to 200 airline APIs, right? And some of them could be slow, some of them. So basically, I wanted to hear something I was looking forward is that when you are calling these APIs, you would have some kind of timeout or something, that you will wait only for this much time. If the API is not responding, for now you will return the results, and later you can refresh the information by retrying or something. So I think you mentioned later about it, that you will retry and exponential backoff, but just having that, just adding this, that I will have some limit on how much I want to wait for these APIs to, because if you're making 200 APIs, some of the tail latencies could be really high, and we said that we want to make a low latency system. So that's why, to keep it low latency, we could have done something there to avoid those tail latencies. And yeah, in the end, yeah, so yeah, again about the staleness, I think we could have discussed more about, so I had to bring up this point of that the airline data would be stale by 1 hour if you are running your job every 1 hour. So those things were the things that could have been brought up by you. Yeah, but again, yeah, I mean, it was 55 minutes. There were a lot of things, so it's hard to cover all of those things, but I think you did really, really good. So thank you.
Yeah, thanks for the feedback.
Thank you, Abhishek. Yeah, I think this was really a good discussion, like a lot of good feedback, and I mean, like Alex also did a lot of good stuff. So any others, like for final feedback? If not, like we can conclude and stop this. Okay, thank you. I'll stop the recording and we can discuss that stuff.